This is a question for the limited factor analysis, and in this question, we will be going through each of the steps required to technically work out the quantities that we will be needing. So for limiting factor analysis, there are a few important steps that we need to follow one by one. The first step is to identify the limiting factor itself. The second step is to find the contribution per physical unit of each product. The third step is to find the contribution per unit of the limiting factor. And then the fourth step is to rank them on the basis of your contribution per unit of limiting factor. And the last and the very important actual working that should be done will be the ranking. We will use the ranking to work out the production plan, the optimal production plan. That's what it's called. Okay, so as you can see the data here, the first data is the direct material, direct labor, variable overheads, fixed overheads, and then selling price, and then maximum demand. And then here we have is the limited availability of the resources, like how much of it is actually available to us, to figure out which one of these two are the limiting factor. So starting with the first step, that is to identify the limiting factor. We'll start with the materials. So the direct material, we can see that there is 10, yeah? 10 is the material required cost per kg, and then this is the 6 pound kg for there are two products, D and G, and then we have this data over here. Now direct material is the cost per unit is 2 pound per kg. Now we need to find out the value for so as we know this we have this value, that's the pound, that is the cost of something, and we divide it by the cost per kg, which is this amount right here. So cost per kg, like this. When we are dividing something with a factor, like which is already being divided, like here, this factor gets pushed over, which means pound will be multiplied by kg and divided by the pound. In this case, the pound gets cancelled, leaving the kg out. So what essentially we are finding is just the material required. We are finding the material required, the required amount, yeah? So as we can see is 10 divided by 2 gave us 5 multiplied by the demand, the actual demand, it gives us 2500, yeah? Next up we move for this was D, and now we're going to calculate for G. So for G, it's gonna be 6 divided by 2, which is 3. 3 multiplied by the demand is 300. This is gonna give us 900. Now as we know, the sum is, we calculate the sum, it's always better to calculate the sum, 2500 plus 900, and it gives us 3400. So the total amount that they require is 3400, and we can see the amount available to us is 300,000 kg. What it says is that our material is actually a limiting factor. So our material is a limiting factor because we need 3400, whereas we have only 3000. Now, which leaves us with a minus 400 that we don't have. Okay, next up we're going to calculate for the labor, and in this one, direct labor, we're going to do 4 multiplied by 500, and then for G we are going to do direct labor equals to 3 multiplied by 300 again. As you can see, this one is going to stay the same, whereas 5 multiplied by 4 gives us 4000. Now this gave me 2900, and we can see that what we actually have is 4000. 4000 is a lot more than 2900, which means the direct labor is not a limiting factor, whereas materials is a limiting factor. Okay, moving on to the step 2. Step 2 is to find the contribution per physical unit of each product. And how you find the contribution per physical unit is by, we need to know what's the formula for contribution, which is selling price minus your variable cost. Now in this, we are not dealing with the material required, but we're dealing with the actual cost involved. And in this case, how we'll calculate is for D, it's gonna be, contribution is gonna be the selling price 50 minus the variable cost, that is 10 plus 12 plus 8, and we're gonna calculate this now. 50 minus 10 plus 12 plus 8. Yeah, so this gives us 20, and we're going to do the same for G. So this is going to be 40, selling price is 40 minus 6 plus 9 plus 10. So that's like 19 plus 6, 25. We're still going to do 40 minus 6 plus 9 plus 10, and that gives us the value 15. So D and G, D has the value as 20 pounds, G has 15 pounds. This is what contribution per physical unit. Okay, that's our step 1. Step 2 done. Oh, sorry, step 2. Yeah, step 2 is done. Going back to step 3, now we need to find contribution per unit of limiting factor. How we'll do that? So for per limiting factor, as we can see, we already have found the contribution here. Now we need to use is the per limiting factor would be 5 and 3. So we divide D by, so the material required, yeah, the material required here 5 and 3, we're going to use these values. So we're going to multiply, because we are trying to find contribution per unit, and these values are 5 pound per unit, 3 pound per unit. Okay, so what we're going to do is divide by 5. This is going to be divided by 3, and we get the value now. We have to go to, so this is what we've done to find the contribution per limiting factor, this and this. Now the step 4 is to rank, so that the one with the higher number gets first. So this is first, This is second. The last step, 5. The last step is to work out a optimal production plan. Now in this plan, what we're doing is we're taking our, so as you can see that for materials, for direct materials, as direct material is the only one that is limiting factor, so we're going to do the proportionation allocation on that one. Okay, so direct material 3 into 300 gives us 900. We've given it all to, we've given the entire 300 out of our direct material 3000, out of our total availability limit 3000. What happens is now 3000 minus 900 gives us the value, minus 900 gives us the value 2100. So we are now left with 2100, but we know that D, the first one, this was for G because it was ranked first, but for D, which is, we can see that the amount required for them is actually 2500, and we only have 2100. So what will we do? So for D, we need to calculate the number of we need to calculate the demand for the D. So we have 2100 that's remaining. We divide it by the material required amount, that is the 5 here, and then it gives us, it should give us the number, which will be 2100 divided by 5. This gives us 420. So we have the demand for 420. You can only fulfill the demand for 420. Now if you want to calculate what's the maximum contribution you can possibly get out of this, so for D, 420 multiplied by 20, this amount, okay, and then plus that with 300 multiplied by 15, so 420 multiplied by 20, 300 multiplied by 15, and that should give us the maximum contribution that we can earn, and it's this one, maximum contribution.